Hello, everyone, and welcome to EPRI FEM2's Senior Design Poster. My name is Christian Fisher. I'm the project lead and a mechanical engineer on the team. Joining me, I have Daniel Kelly, an electrical engineer, and Jason Kenny, also an electrical engineer. EPRI FEM2 is a continuation of the EPRI FEM team's senior design project. The project focuses on analyzing the loads that porcelain post insulators are subjected to during their normal use. Those insulators are used on high voltage power equipment in switches, transmission lines, and other structures. Phase 2, which is this senior design team's project, was tasked with designing and building a test frame to simulate combined loading conditions of compression and torsion and record their data. This kind of testing has never been performed, so the project was carried out from the ground up. The test frame is capable of fitting insulators from 10 inches to 168 inches and can provide up to 350 kilonewtons of compression and 8,500 newton meters of torsion.
Our test rig consisted of 5 different subsystems: the frame, compressive load applicator, torsional load applicator, hydraulics, and controls. These 5 systems all work together to have a completed porcelain insulator compressive and torsional tester. This project is continued from last semester, but there were still some changes and fixes to be made. Last semester we planned on making the scaled down model, but we ended up making the full scale test rig instead. Some mechanical parts were changed and some parts were added or removed. For the controls, the safety relay was removed and we are now using 2 e-stops. These e-stops are connected directly to the main power so that when they are pressed they shut everything down. Mechanical changes include larger plates for the CLA so that it can easily slide along the rail. This is needed to be addressed so that it could withstand the forces from the TLA.
The operation of the machine begins with powering it up and turning the pump on. Once the screen turns on, you'll be able to select the type of test you wish to complete, as well as the upper and lower limits of the data capture. When selecting the test, the user has the option to test a torsional load, a compressive load, or test both simultaneously. The test will run until the stop button on the touchscreen is pressed, or if one of the emergency stop buttons are pressed, or when the insulator breaks. This will direct all of the hydraulic fluid back to the reservoir, creating a safe environment that the operator can now reach into. This is an overall model of our project. And at this time, we would like to thank our industry supporter, EPRI, as well as our faculty mentor and UNC Charlotte for giving us this opportunity. Thanks.